All right, this is Unit 4, Lesson 1, Inverse Variation and the Reciprocal Function. So our lesson essential question is, how are inverse variation and reciprocal functions related and represented? By the end of this lesson, you will be able to use inverse variation and graph translations of the reciprocal function. All right, example 1, identify inverse variation. So how do you determine if a relationship represents an inverse variation? So A, does the table of values represent an inverse variation? So I have 1, 12, 2, 6, 3, 4, 4, 3, 6, 2, and 12, 1. An inverse variation is a relation between two variables such that as one variable increases, the other decreases proportionally. For the table to represent an inverse variation, the product of x and y must be constant. Find the product xy for each column in the table. So I just multiply 1 times 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2, and 12 times 1. Well, they all get 12. Since the product of the values is constant, meaning they're all the same, the table of values represents an inverse variation. How do you determine if a relationship represents an inverse variation? So does this table represent an inverse variation? 120, 217, 314, 411, 58, 65. I find the products. I get 20, 34, 42, 44, 40, and 30. Since the products are not constant, the table does not represent an inverse variation. Okay. So I want to determine if the table of values represents an inverse variation. Fill in the table. So I'm multiplying x times y. So I have 1 times 25.5 is 25.5. 2 times 12.75 is 25.5. 3 times 8.5 is 25.5. 5 times 5.10 is 25.5. 6 times 4.25 is 25.5, and 15 times 1.70 is 25.5. So this is an inverse variation. Okay. I'm going to do the same thing with this one, x times y. 6.6 times 3 is 19.8, 5.5 times 5.5 times 5 is 27.5. I can stop there. They're not constant, so it's not an inverse variation. This, I would probably do a third one. But again, this is not a variation. All right, so concept, inverse variation. When a relation between x and y is an inverse variation, we say that x varies inversely as y. Inverse variation is modeled by the equation y equals k divided by x, or with an equivalent form, x equals k divided by y, or x times y equals k, where k is not 0. The variable k represents the constant of variation, the number that relates the two variables in an inverse variation. So in this table, the constant of variation is 24. So when I multiply, notice that as x doubles in value from 1 to 2 to 4 to 8, the value of y is halved from 24 to 12 to 6 to 3. When I multiply these, I get 24. That's my constant of variation. All right, example 2, use inverse variation. In an inverse variation, x equals 10 and y equals 3. Write an equation to represent the inverse variation. Then find the value of y when x equals -6. Okay, so in order to find the inverse variation, I write the equation, y equals k over x. I was given x and y, so 3 equals k over 10, or 30 equals k. After solving for k, I write an equation for the inverse variation. So y equals 30 over x. I write the equation to represent the inverse variation. Now I substitute a -6 for x, and then I divide. 30 divided by -6 is -5. So the equation that represents the inverse relation is y equals 30 over x, when x equals -6, y equals -5. Okay, so if an inverse variation, x equals 6 and y equals 1/2, I want to write the equation that represents the inverse variation. So I have y equals k over x. Okay, so y is 1/2 equals k over 6. So I need to multiply 1/2 times 6, which equals k. So 3 equals k. So my equation is y equals 3 over x. Basically, I'm just multiplying these two together. That gives me my k value. And I want to know what the value of y when x equals 15. So I have y equals 3 over x, which is y equals 3 over 15, which I can simplify to y equals 1/5. All right, example 3, use an inverse variation model. On a guitar, the string length S varies inversely with the frequency F of its vibrations. So basically, S is our X value and F is our Y value. A capo is a clamp that effectively shortens the strings on a guitar. The frequency of a 26-inch E string is 329.63 cycles per second. What is the frequency when the string length is 13 inches? Okay, so the frequency, I write the inverse equation, S equals K over F. Remember, S is our Y value, F is our X value. So 26 equals K over 329.63. I multiply, I get K equals 8,570.38. After solving for K, I write an equation for the inverse variation. So I substitute in 8,570.38 for K in the equation. And then I substitute in 13 for S. So I get F equals 659.26. So the frequency of a 13-inch string is 659.26 cycles per second. So the amount of time it takes for an ice cube to melt varies inversely to the air temperature in degrees. At 20 degrees Celsius, the ice will melt in 20 minutes. How long will it take the ice to melt if the temperature is 30 degrees Celsius? Okay. So we're going to use I equals K over the air temperature. So at 20 degrees Celsius, the ice will melt in 20 minutes. So 20, the ice melts, equals K over 20. So to solve for K, I do 20 times 20 equals 40. So 40 equals K. So then I have I equals 40 over A. Okay, and I want to know how long it will take at 30. So I have I equals 40 divided by 30. So 40 divided by 30 is 1.3 repeating. So approximately 1.3 repeating. So approximately 13 minutes. 13.3 minutes. All right, example 4, graph the reciprocal function. How do you graph the reciprocal function? Y equals 1 over x. So my solution, the reciprocal function maps every non-zero real number to its reciprocal. So consider the domain and range of the function. The domain of x, where x does not equal 0. If x equals 0, then that will result in an undefined expression. So x can't equal 0. And the range is y, where y is not equal to 0. So if I graph the function, I use the table of values or technology to graph the function. -3, -1/3, -2, -1/2, -1, -1, -1/2, -2, and so on. Okay, and I get this function here. Observe the graph of y equals 1 over x as it approaches positive infinity and negative infinity. As x gets larger, the denominator gets larger and the value of the function approaches 0. An asymptote is a line that a graph approaches. Asymptotes guide the end behavior of a function. As x approaches infinity, f of x approaches 0. The same is true as x values approach negative infinity, so the line y equals 0 is a horizontal asymptote. I can also observe the graph of y equals 1 over x as x approaches 0 for positive and negative x values. Notice as x gets closer to 0, the values of the function get larger and larger. For positive values of x, as x approaches 0, f of x approaches positive infinity. As x gets closer to 0, the value of the function approaches negative infinity. For negative values of x, as x approaches 0, f of x approaches negative infinity. The domain of the function excludes 0, so the graph will never touch the line x equals 0, and the line x equals 0 is a vertical asymptote. So you can see in the graph, these two blue lines here that are dashed are my vertical and my horizontal asymptote. So I will never touch 0, this line. It will come really, really close to it, and it will get closer and closer and closer over time, but it will never actually touch 0. Okay. So it wants me to graph the function y equals 10 over x. What are the domain, range, and asymptotes of the function? Drag the points on the graph to change its shape. Drag the gray point to change the location of the asymptotes. Okay, so I'm going to go ahead and pick a couple values for x and y. So if I let's pick some easy values for x. Let's go with x equals 1. I can't do x equals 0, so that tells me that there is a horizontal asymptote there. Okay, so if x is 1, 10 divided by 1 is 10. So at 1, y equals 10. So when x is 1, y equals 10. Okay. So that gives me that one, which means at negative 1, this gives me negative 10. At least gives me a point. Okay. So if I'm graphing this, as I can see, it's going to get closer and closer to 0. So if you look at this, it gets closer and closer to 0, but it never actually touches. And it does that on both graphs, both the x and the y. So my domain is x, but x cannot equal 0. Range is y, where y not equal 0. Asymptotes are t equals 0 and y equals 0. Okay, they picked 5, negative 2, and 5, 2. Again, you can pick any values that you want for x. I would notice that 10 is easily divisible by 1, 2, 5. Its factors, those are probably going to be the easiest ones for you to graph. All right, example 5, graph translations on the reciprocal function. So graph g of x equals 1 over x minus 3 plus 2. What are the equations of the asymptotes? What are the domain and range? So start with the graph of the parent function, f of x equals 1 over x. Recall that f of x plus h translates the graph of f of x horizontally, and f of x plus k translates the graph vertically. Okay, so this translates horizontally, this translates vertically. Okay, so horizontal negative 3, so I'm going to go 3 units to the left, and plus 2, 2 units up. Okay, so I shift horizontally and then I shift vertically. The vertical asymptote is shifted 3 units to the right and 2 units up. Minus 3, I shift 2 to the right, 3 to the right, 2 units up. Okay, so the domain is x, where x cannot be 3, and range is y, where y cannot be 2. This gives you the asymptotes. Just so you know. Okay, so I want to graph 1 over x plus 2 and negative 4. Well, this is an asymptote, and this will be an asymptote. This tells me I moved 2 units to the left and 4 units down. So I'm going to go 2 units to the left, 1, 2, 4 units down. This is where my asymptote is. Okay, now I'm going to pick a number. So my asymptotes is x equals 2, y equals negative 4. The mean is x, where x cannot equal negative 2. Range y, where y cannot equal negative 4. Okay. So again, I can pick any value that I want. So let's say I pick so if I do 1, I do 1, that gives me 1/3. So 2 gives me 1/4. So 1/4 minus 4 is 3.75. So when x is 2, it's right here. Y is negative 123.75, so really close to this right there. Okay, same thing here. If I do negative 2, that would give me 0. So if I do negative 4, that's going to also give me, so 1 over negative 1/4 minus 4 gives me negative 3.75 again. 0.25 negative minus 4. It's negative 4.25. Here, it's about right there, somewhere there, close to that. Okay, so x is negative 2, y is negative 4, horizontal, vertical asymptotes. Domains, x can't be negative 2, range, x can't be negative 4, and then, of course, my graph. Here's my values. Again, you can use whatever values you want. All right, concept summary, inverse variation and the reciprocal function. So inverse variation is a relation between two variables such that as one variable increases, the other decreases proportionally. Okay, basically you're multiplying your x and y together, that gives you your k value, where k cannot be 0. So I have y equals 1 over x. That is the traditional parent function for this. My asymptotes are at x equals 0 and y equals 0. Okay, so again, when you transform the reciprocal function, it still models after that parent function, the y equals 1 over x. Like other functions, it can be transformed. I have y equals a over x minus h plus k. So if I do minus 4 on the bottom and minus 2, that tells me I'm going over to the right 4 and down 2. Remember, it's the opposite sign. Parent is transformed down 2 and right 4. Asymptotes are x equals 4, which is right here, and y equals 2. Negative 2. And that is the end of Unit 4, Lesson 1.